Next, let's see the counter instruction. In the counter instructions, you will get two different counter, up and down counter. Up counter means it will add the pulse. Down counter means it will subtract the pulse. Counter output will be high when the actual value is greater than or equal to the set point. The values can be between the 00000 to 9999. This is the counter block. Here you can see the different functions: direction, reset, count, and the out. So this out is the counter output. This direction bit is to give a direction for the counter for up and down. Reset to reset the actual value. And a count for the counting the pulse. So in the direction, if it is a 0, then the counter will act like a up count. If the direction bit is I, then the counter will be act like a down count. For every count pulse, the counter will be incremented or decremented by 1 depending on the direction bit. And once you give a reset signal at RES, the counter will be resetted to 0. Let's see this in the software. I'm taking one input signal and the counter you have to select from the counter relay, click and drag and leave it on the output side. And for the counter output, select the counter relay and leave in input side. And then I'm going to select the output. To set the parameter for the counter, select the counter. In the down, you can see the properties. In the circuit diagram element, here you can select the counter address. I am selecting C1. And in the coil function, select the count pulse. In coil function, you will get a different operation. Count pulse, count direction, reset. Now I am selecting the count pulse. And in the parameter, you can select the set point. I am going to set the 5 as my set point. Then click on the simulation, start the simulation, and in the display, select the counter relay. This C1 is my counter, set point is 5. And this is my input. For every input signal, means for every transaction from 0 to high, your counter will count for 1. So I am giving my input signal. Now you can see my actual value is incremented by 1. Again, if you remove your input signal and if you are giving an input signal, then that actual value will increment by 2. Means for every input signal, the counter will count for 1. And when it is equal to the, when the actual value is equal to the set point, then your output will become I. After that also, if you are giving an input signal, it will be incremented and your output will remain high. Now, to reset this counter output C01, okay, you have to take the reset coil for the counter. Further, go to the circuit diagram and select one more input, I2, to reset the counter. Select the counter relay and leave on output side. In the coil function, select the reset and make sure the timer address is C01. Now go for the simulation, click on run, select the counter relay in the display and start giving the input signal. Once your input signal, the value is greater than or equal to 5, your output will be on. And then If you want to reset your counter output, you can give a signal at I2. Once you give the signal at I2, your counter output will be reset to 0 and actual value also goes to 0. This is for up counter. Next we'll see how to use this counter C01 for down count. For that, I am taking one more input for the direction I3. And then I am going to select the counter relay. And in the coil function, select the counter direction. And make sure the counter address C1. And then go for the simulation. Start the simulation and click on the counter relay display. Okay, so this is my counter C1. Now I give the input pulse at I1 and you can see my direction is in 0. Means now the counter will act for up count. Once I start giving the pulses, you can see my actual value is incrementing by 1. And your output will be enabled when the actual value is greater than or equal to set point. Once you enable your direction bit, that is I03, then if you give an input pulse, then it will decrement by 1. You can see that my actual value is decrementing. When the actual value goes less than the set point, then your output will become 0. Now you can see my actual value is 4, which is less than the set point. So output is in 0 state. If you remove the direction bit and then if you are giving an input signal means, then it will increment by 1. Now the actual value is equal to the set point. So my output is in I state. In between of your program running, if you want to reset the counter output, then you can give the signal at I2. Then the counter will be resetted to 0 and output will go to 0 state. Always remember the direction bit. Suppose if you want your counter to act like up count, then make the direction bit in the 0 state. If you want the counter to act like a down count, then you have to give the I signal at the direction.